Good evening. Myself Rashmi and I am from Karnataka and my today's topic is gravitation. Well, besides developing three laws of motion, Sir Isaac Newton, he was very much interested in the motion of celestial objects such as planets and moon. He examined that some forces acting on the planet, and because of that force the planets are following circular or elliptical orbits. In the absence of that force, these planets, they would have moved in a straight line, or else they would have moved straight. That means there is some force which is making these orbits to follow a circular orbit. He also notices that or else he also wondered that what force must be acting between two planets when they are separated with a lot of distance. He also finds that an apple is being attracted by earth. With all these questions, with all these thinkings, he finally comes out with a law through a series of experiments. And that law we study as Newton's law of gravitation. And this Newton's law of gravitation is a universal law. That means this law is not only valid on earth, but it is also valid in the outer space, or it is valid in throughout universe also. So that law we call it as Newton's law of gravitation. And besides this law, this gravitational force is an attractive force in nature. That means this gravitational force attracts every other object which has mass. This gravitational force is always attractive in nature, and we do not find any repulsive force as we find in case of electrostatic force. So let us see the statement, what the statement is. So the statement says every particle in this universe is attracted by another particle with a force of attraction, and this force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let's see what this statement is saying. Let me consider two objects having mass m1 and m2. Let these masses be separated by certain distance d. Now, according to Newton's laws of gravitation, he says the gravitational force of attraction between these two masses is directly proportional to the product of two masses, which says as the magnitude of this force increases, the magnitude of the gravitational force between these two masses also increases. And since the gravitational force is attractive, I'll put an arrow mark over here. Then the second part of the statement says that the gravitational force is inversely proportional to the square of the distance between them. See here, actually the experiment was like this. See, when the distance earlier at this distance for these masses the force was some F. Then through experiment, when the distance between them was increased, or if the distance between them was increased twice, that time they found that whatever the force which was existing, it got reduced. When it reduces, obviously we will come to a conclusion that force is inversely proportional to distance. But through experiments we got to know when the distance was increased twice, the existing force decreased by 4 times. If the distance was increased thrice, the existing force decreased by 9 times. That means the forces, it is inversely proportional to the square of the distance. As the distance increases, force is reducing. It is following inverse square law. And based on these observations, let me consider this as equation 1, this as equation 2. Then from these first and second equation, we can write F is directly proportional to M1 and M2, and it is inversely proportional to square of the distance between them. That is F is directly proportional M1 and M2 divided by D square. So next F is equal to, now I would like to equate these two terms. So F is equal to, if I want to equate, then we are supposed to introduce a constant, and let us consider that constant as G here, G into M1 M2 by D square, where G is a constant called as gravitational constant. G is a constant called as gravitational constant. So further, gravitational constant, and the value of G is found to be 6.67 into 10 power minus 11 Newton meter square per kg square. So this is all about Newton's law of gravitation. With this law, we can find out the gravitational force between any two objects. And we can also define what the gravitational constant is. So here I can write F is equal to G. Now I can define what the gravitational constant is. If M1 and M2 is equal to 1 kg and the distance of separation between the two masses is 1 meter, then all this part will become 1. At that time, the gravitational constant will be equal to the force between two masses of 1 kg and between two masses of 1 kg, and the distance of separation between them is 1 meter. That means if these two masses are 1 kg each, and if the distance of separation is 1 meter, then whatever the force of attraction arises, that is the gravitational constant, and its value is 6.67 into 10 power minus 11 Newton meter square per kg square. Thank you.